welcome to video number 6 on my videos about solving differential equations by separating the variables. So here we're going to find a particular solution of a differential equation x plus 4 dy by dx minus x cos squared y is equal to 0, and we're told when x is 0, y is pi over 4. So writing that out, so we've got to separate the variables. So you might want to stop now and think, what would I do to separate the variables? You might just want to pause the video for a minute. Okay, so what we're going to do to begin with is we're going to take this, we're going to take it to the the right hand side. So we end up with x plus 4 dy by dx is equal to x cos squared y. Then we're going to take this over here and this over here. So we're going to have 1 over cos squared y dy by dx is equal to x over x plus 4. We've now separated the variables, so we will now integrate on both sides. But we will write 1 over cos is that sec is 1 over cos. So we will now write the integral of sec squared y dy, that's 1 over cos squared dy. Okay, we're integrating both sides with respect to x, and is equal to the integral of x over x plus 4 over dx. Now you should recognise this as an improper algebraic fraction because the powers of x are the same. So if the powers of x are either more in the numerator is more or the same as the highest power in the denominator, is considered to be an improper algebraic fraction. And therefore you need to divide first. So we need to do x plus 4 into x. So x goes into x one time. You multiply out 1 times x gives you x. 1 times 4 gives you 4. And then we do a subtraction, 0 minus 4, which gives you minus 4. So the integral now becomes the integral of sec squared y dy is equal to 1 plus the remainder, which is minus 4, over the divisor, which is x plus 4 dx. So I'm going to write that out on the top of the next slide. Right, the integral of this is actually quite easy because we know the differential of tan x is actually sec squared x, so it makes life easy for us. So this will become tan of y. Integrate 1, you're just going to get x, and if you integrate this, you're just going to get 4 ln of x plus 4 plus c. We're given some information, so when x is 0, y is pi over 4. Well, that's good, because tan of pi over 4 is 1. It's going to be equal to 0 plus 4 ln of 0 plus 4 plus c. So this will become 1, and this bit here will become 4 minus 4 ln of 4 plus c. Therefore, c will be 1 plus 4 ln of 4. So tan of y will be x minus 4 ln of x plus 4 plus 1 plus 4 ln of 4. So we could actually combine these two logs together. So using all the rules of logarithms, I'm not going to read them out, you should know them. We're going to apply them. So we've got a minus here. Okay, so we've got tan y is equal to x ln of 4 over x plus 4 to the power of 4. So we take the 4's up in both cases, and then we've got this one minus this one. So we're using this rule here and this one really. Okay, we've also got a plus 1. Okay, so writing that out again. Okay, I'm going to bring the 4 back down because it might make it a bit neater, and then to make y the subject, we'll do tan to the minus 1 of all of this. So we'll do the 4 down in front, 4 ln, x plus 4 ln of 4 over x plus 4 plus 1. Okay, so this has been a video to show you how to solve a differential equation by separating the variables. So I hope you've understood, and I thank you very much for watching, and maybe you could consider subscribing to my channel, and you will find the links to all my resources in the notes of this video. Thank you very much.